Welcome. Today's lesson is over how to add integers. Again, what are integers? Integers are whole numbers, 1, 2, 3, 4, 5, and their opposite, -1, -2, -3, -4, -5. Don't forget 0. So we have -10 and absolute value of -10. Write down two ways these numbers are alike and two ways they are different. Every year I have some students who make a T-chart like this one, alike and different. What makes these alike? Both of them, I see 10 and 10. I both see a negative sign somewhere. Negative sign, negative sign. What makes them different? One of them has an absolute value, other doesn't. Well, let's answer this. So -10 is just -10. Absolute value of -10. So here is a number line. Here's 0. Here's -10. How far or how many units from 0 to -10? Let's count. -1, -2, -3, -4, -5, -6, -7, -8, -9, and -10. Let's count how many units that is, or how many steps taken. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the absolute value of -10 is 10. So the solution is 10 and -10 and 10. So that's why it's different. There are many other ways to say it, but that's just the thing. So today we're going to be talking about addition of integers using algebra tiles. You'll be getting these algebra tiles, or the little tiles. The yellow counters represent the positive integers, and the red counters will represent the negative integers. When you put a yellow counter with a red counter, or a positive integer with a negative integer, what's going to happen? They are going to cancel each other out. Think of it as zero pair. A positive and a negative cancels each other out. We will call that a zero pair. So let's look at our lesson for today. So using your algebra tiles, we'll have right here these, determine each sum. Show your work using drawings and with a number line. For drawing purposes, use positive for plus sign for positive integers and negative sign for negative integers. A positive cancels out with a negative to equal 0. This is called zero pair. So let's use algebra tiles. So we start with what integer? -7. Please take out 7 negatives. 1, 2, 3, 4, 5, 6, 7. We're going to add some more tiles to this. We're going to add 5. 5 is a positive. So what happens when you have a negative with a positive? A positive will cancel out a negative to make z equals 0. This is called zero pair, zero pair, zero pair, zero pair, zero pair. So we are left with -2. Let's draw this and show this. So we start with 7 negatives. 1, 2, 3, 4, 5, 6, 7. We're adding 5 positives. These are called zero pairs. So we draw an arrow saying goodbye, because a negative and a positive, or a positive and negative together, will cancel out. So what are we left with? -2. The sum is -2. Now let's draw a number line. So you always begin at 0. And you move, so the first integer was -7. So we're going to move blank units to the left. We're going to move 7 units to the left. Stop. And then we're going to add another integer to that, 5. How would you describe 5? As a negative or a positive? We're going to move 5 units, positive number. Remember, the number line goes from least to greatest. So we know the greater numbers are on the right-hand side, so we're going to go right 5. 1, 2, 3, 4, 5. And we stopped at What number right here? Negative 2. So we begin at 0, and you move 7 units to the left, and then move 5 units to the right. So it's equal to negative 2. Next example. Negative 4 plus negative 4. Are these parentheses absolute value? No, they're just parentheses. The reason we draw these parentheses, it just makes it easier to read. Because if I had written it like this way, or typed out like this way, would that be very confusing to you? Yes, because you see negative 4 plus, it's just so many things there. So we put a parentheses around it so it's easier to read. So let's use algebra tiles. So negative 4, we start with negative 4. That's what we are starting with. We are adding, wait, we're starting with negative 4. We are going to add 4 more negatives to this picture. Do you see any zero pair? Do you see anything that cancels out? No. So the sum must be negative 8. Let's draw this. So we draw 4 negatives. I add 4 more negatives to this picture. Do you see anything cancel out? No. So let's use our number line. We begin at 0. So we're here at 0. Negative 4. Would negative be to the left or to the right on the number line? It is to the left. So we go 4 units, move 4 units to the left, to negative 4. Then so second number is negative 4. Is that to the left or to the right? Well, negatives are to the left. So we move 4 more units to the left. And we stop at negative 8. Next example, 8 plus negative 11. I'm going to draw these. So we have 8. We start with 8 positives. We're going to add 11 negatives to this picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What happens when you put a positive and negative together? They become 0 because they cancel out. So all of these will cancel out. Bye-bye. What do you have left as a sum? Negative 3. So 8 plus negative 11 is equal to negative 3. Let's use a number line. You always start at 0. You go 8. 8 units. 8 is positive, so it goes to the right. Then the second number, you're going to add another arrow. You're going to add negative 11. Negative 11 means to the left. So go back 11 units. 8, 9, 10, 11. It stopped at negative 3. Our fourth example. Start with negative 2. So I start with negative 2, negative 1, negative 2. I'm going to add 9. 9 is a positive. So I'm going to add 9. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'm going to add 4 negatives to this picture. 1, 2, 3, and 4. What happens when you put a positive and negative together? They all cancel out. So all of these are removed, and we are left with 3, positive 3, or 3. Let's use a number line. Again, we start at 0. The first number I need to show an arrow for is negative 2. Negative 2 means to the left, to the negative. So I go 2 units to the left. Plus 9. 9 is positive, so 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm stopped at 7, as you can tell. Then the third integer is negative 4. That's 4 units to the left. 1, 2, 3, 4, and eventually I stopped at 3. So our next example is negative 3 use my algebra tile. I'm going to add two more negatives to this. 1, 2. Then the third example is a little more tougher. This is absolute value. So what's the absolute value of -8? Here's -8 right here. How many units from 0 to -8 are there? How far is it from 0 to -8? It is 8 units. So it's this absolute value of -8 is just 8. So I take out +8. 3, 4, 5, 6, 7, 8. Again, what happens when you put a positive and negative together? All these becomes 0 pairs, and we're left with a sum of 3. Again, you can graph this. We start as 0. -3 means 3 units to the left. -2 means 2 units to the left. And absolute value of -8 means 8 units to the right. And it stops right here at 3. So our last one is a challenge. In the morning, Paul deposited $3 to his checking account. Woohoo! Deposited $3. Then he withdrew $10 from the ATM. Ooh. In the evening, he transferred $5 to his checking account. Woohoo! Would like the change in his checking account as an integer. So we have 3 plus withdrawal. When you withdraw $10, is that positive or negative? That's -10 plus he transferred $5. That's a good thing, $5. So we have 3 plus -10 plus 5. So let's draw this. 3 positive, add 10 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add 5 positives. 1, 2, 3, 4, 5. All of these become 0 pairs. And we are left with 2. Oh, it's right as an integer. So the answer is 2. And our last one is Paul withdrew $8 from the bank. How do you represent this as an integer? Withdraw $8. That is -8. And that would be, as a griddable, you would write in -8 and you put -8. All right. And that is how to add integers using algebra tiles, drawing, and number line.